Hey, I'm going to start with 8.0 Homework 21, Introduction to Exponential Function. What is an exponential function? Well, you know two functions so far you've really been familiar with. The first one is a linear function. A linear function is a function that has a straight line in some form. That's a linear function. The second type of function you become acquainted with is the quadratic function, which always renders a parabola in some way or shape or form. This is the third kind, and that is an exponential function. Exponential function is of two kinds. One is where it starts off really slowly and then it rises up dramatically because it's rising exponentially. Or, or it could be starting from a really great height and then shrinking at a vast rate and eventually leveling off and never quite touching the x-axis in either direction. And when that happens, we say that it is asymptotic. It's an asymptotic curve because it never quite touches the x-axis at any point. And the reason for that is that it can't, because there's no exponential function. Even if you go down to zero, that's going to give you a y of zero. You're always going to get some value. Like the lowest you can go is like, remember the functions of 10 to the first is 10, but 10 to the 0 is going to be 1, and 10 to the negative 1 is going to be 1/10, and 10 to the negative 2 would be 1 over 100, or 0.01. And you're going to see that no matter what happens here, 10 to the negative 10 would just be 0.00000. But there's always going to be some 1 lurking back there. 1, 2, 3, 4, 5, 6, 7, 8, and then 9, and then 10. And it's never going to exactly equal 0. That's called asymptotic. So that's just a term you should be familiar with in case you're rear its head. Now, what's going to happen here? We're going to get a collection, 6 of these to evaluate based on that knowledge. They're really not hard until you get to one particular piece, which we'll talk about when it comes. Okay, so let's start these off. This is really easy. The general function of an exponential function is f, let me fix that, sorry, f of x is equal to a times b to the power of x. Okay, there's always going to be some constant and then some base risen to some x value. Another way to recognize an exponential function is that the x is actually the exponent in some way. So this is what's happening here. Now, this is a weird kind of problem because it's asking us to find the function that includes x of 0 and an f of x of 12, at the same time x of 3 and f of x of 1500. And it's really odd what we're going to do. What we're going to do is treat it almost like a system of equations, okay, where you've done cancellations and substitutions. We're going to do a little bit of both, but the key principle is here. You remember you had like an x plus y and an x minus y, and you added the two lines, you get 2x and the y's cancel out. You're adding the two lines together. This is going to have a counterpart, but not quite the same thing, but similar. So keep that in mind, and this may make sense to you. I'm going to leave that drawing structure there. What's going to happen here is that we need to plug in our function. Okay, so if x is 12 and f of x is equal to, if x is 0 and f of x is equal to 12, then you said 12 is equal to a times b to the 0 power. That's your first setup. The second setup, if x is 3, f of x is 1500. So 1500 will be equal to a times b cubed. Okay? The only thing you have to do with these, which are really simple, is understand that b to the 0 is 1. Anytime you see anything to the 0 power, it's 1, which is great, because what that ends up doing is canceling out this value. You end up getting a is equal to 12, and you plug that into the second function. So 1500 is equal to 12 times b to the third power. Obviously, the first thing you're going to do is figure out what is 1500 divided by 12. 1500 divided by 12 will give you 125, which is notable because 125 is a perfect cube, which kind of makes sense because if you're going to get a problem like this, we know that you're going to get some number cubed gives us 125. That's going to give us b of 5. If you know b of 5, you have a of 12, you have the entire thing. F of x will be equal to, what the hell is that? 12 times 5 to any power, and that should work. So let's try it out. Putting 0 in here, obviously that's going to disappear and become 1. Okay, you get your f of x is 12. Putting 3 here, 5 times 5 times 5 is 125, and 125 times 12 is in fact 1500. So you're done. So in this case, A is 12, and B is, what was it, 5? I'm going to put that in, submit it. Don't think too hard about this one. This is actually really easy. To show you how easy this is, we're going to do one on the fly, okay? Because it becomes easy. Okay, just like this, we did it before. Remember, I got to remember not to do that. F of x is equal to a times b to the x power. But if it's going to be 4 equals a b to the 0 power, you remember that b to the 0 power is 1, therefore a is 4. We're done with that one. It's done. It's that easy. Now, 16 is equal to 4 times b squared. And what's that going to give you? Well, it's going to give you a perfect square in this case. So you're going to divide 16 by 4. You're going to get 4 is equal to b squared, which obviously is going to lead to b equaling 2. So now you have your b. So a is 4 and b is 2. Okay, so we're going to put that in. And those are really easy once you get the idea. And then we're done. The only issue is that thing that comes up, it gets a little tricky. You get a slightly different version of this problem, which does involve a little bit more work. So we got to look at that. All right, so this is the next version. Same thing, except you don't have that little gift of having x to the 0 power. We're going to have to do it a different way. But again, it's really not hard. It's just tricky hard, if that makes any sense. Okay, so if x is -2, b was 2 over 25. Okay, so that set it up. F of x is equal to a b to the x power. In this case, 2 over 25 is equal to a times b to the -2 power. I would leave that alone for right now. We'll deal with it later. Let's look at the second one. The second one is 250 is equal to a times b to the 3rd power. Okay, now what are we going to do here? We're going to set it up in such a way that we're going to create a system, if that makes any kind of sense. So we're going to do 2 over 25. All right, so 2 over 25. One thing that occurs to me is you might think about, in this case, make an exception, turn this into a decimal. I might make it a little bit easier. 2 divided by 25 gives you 0.08. So I'm going to actually change my advice. I would change this to the equivalent. What was that again? 2 divided by 25, just to make it a little bit easier. 0.08. Okay, so we're going to do, instead of that, we're going to replace this with its decimal form, which is 0.08. Okay, I'll tell you why that's going to be useful, because it'll make it a lot easier. Okay, and we know that it's going to be a b to the -2 power. And we're going to not add, not subtract, but divide. And what will that do? It'll a divide a, it'll be a 1, it'll cancel itself out. That's the advantage of this. So let's do 250 divided by 0.08. 250 divided by 0.08 is equal to 3,125. Okay, so we're going to use that. 3,125 is 250 divided by 0.08. A divided by 8 is gone. It cancels out. Don't think about it. Now remember, when dividing bases with exponents, the rule is if you're going to divide them, you subtract them. What you end up with is b to the power of 3 minus a -2, which is going to equal b to the 5th power. Okay, so 3,125 is some value of b raised to the power of 5. At this point, it helps to remember our rules for inverting. Okay, we know that some number multiplied by itself 5 times is going to give you this, and that's easy to do. Just remember that we can take the exponent that's going to cancel this out to make up b to the 1 power, and that's to multiply 5 by 1/5. Okay, or 0.2. Okay, decimals do help this time around, I will admit. Okay, so you're going to take b to the 0.2 power and get just b, right? 5 times 1/5 or 5 times 0.2. Same thing, you get b to the first power. And if you do it to this side, you'll do it to this side too. So another thing you have to do is do 3125 and raise it to the power of that same 0.2, and you'll see it's a 5. Okay, so that's going to give you our answer. I'm going to get you that in a second. So we're going to get b to the 1 is equal to 5. In other words, b is equal to 5. Okay, now that doesn't give us a yet, but it's going to get us there. B is equal to 5. So you know you have a function called y is equal to a times 5 to the power of x. Okay, I'm hoping that's making sense so far, because that does give us b. We don't have a. We do have to figure it out. And that's going to be easy too. We're just going to plug this value in, right? The same thing you do with the system of equations. 250 is equal to some value of a multiplied by b to the power of 3. Okay, and we know that b is 5. So we're going to solve that by doing that. That's going to give us b times b times b is 125, or 125a. And 250 divided by 125 is easy. It's 2. A is equal to 2. So now you have your a, your b. Your entire function will be f of x is equal to 2 times 5 to the x power. And that's what we're going to put here. Okay, that's what goes in there. So we're going to put exactly that. We're going to put 2 parentheses, okay, 5 to the power of x. And it should take that, not uppercase x though. I have to change that. Lowercase x. Try again. Okay, that should take it. Okay, it should work. It didn't take it. I'm not sure why. So I'm going to see what is going to happen here. I'm going to assume that it's not an exponent. I see the problem. It's got to be raised to the little x power. That should work. Okay, submit. So something to be careful about. I just want to try out and see whether it will take 2 times 5 to the x power, just to see whether that would work. Okay, something like this instead. Let me clear the screen so you can see it. And submitting that. Oh, that stupid bar. Hang on, okay, I had to let a siren go by. The question is whether this will take that form. And submitting it shows that it does in fact take that form. It'll take either one. So you can put parentheses in, you don't have to put parentheses in, but I hope that makes sense. Okay. If you want a similar one, I'll do one super quick. Same kind of deal here. So let's do the first one. F of x is equal to okay, in this case, 5 over 9, not such a great decimal value this time, is equal to a times b to the negative 2 power, and 45 is equal to a times b squared. But the same thing is going to happen here. Okay, so we're going to take the 45 and equal to ab squared, and divide it by 5 over 9 is equal to a times b to the negative 2 power. The easier one is this one. 2 minus negative 2 is b to the 4th power. Now, 5 over 9 is not such a great decimal. Right? 5 over 9 is a non-terminating value, 0.5555. So it might be better to look at this one another way. So what I'm going to suggest is that you do this instead. 45 divided by 5 over 9 is the same thing as 45 times 9 over 5. And now if you do that, that's a little bit easier, because if you look at 45 divided by 5, you'll see that that's equal to 9. And if that's true, then your answer would be 81, which is much easier. Okay, and you can do the same thing of multiplying by the inverse of 4 to get your thing, but that's 0.25. Okay, and you can do that too. So 81 to the 0.25 power is going to give us an answer of 3. But I'm going to just verify that. 25 power gives us 3. You could also do it to the power of 1 over 4, and you still get the 3. Either way, you still get 3. And that's going to tell you that b is equal to 3. So b is 3, and a is still not determined. We have to seal that one. Okay, so if b is 3, then we're going to look at this one. And 45 is equal to a times 3 squared. 3 squared is 9. Okay, and 45 divided by 9 is 5. So 5 is equal to 8. And we're done with this problem. The function will be, therefore, y is equal to 5 times 3 to the power of x. And that should work. Submitting tells us that is correct. I hope this is making sense. Please go slowly with these. We have 4 more questions to do. Okay. Now, okay. We have to talk about this one. We're talking about an investment and investment rates. I have to give you a really, really succinct overview of what we're doing here. Okay, this is a compounding interest problem. And compounding interest has a number of variables. You've got a general form of FV equals PV times 1 plus R over N raised to the NT power. This is a lot of stuff, right? But it's not really all that big of a deal. So if you just remember a couple things. The first thing you have to remember is that FV stands for future value. The value in the future is equal to the value in the present. Okay, so this stands for present, multiplied by 1 plus the interest rate. Okay, R stands for interest rate. N stands for number of times it's being compounded. And the exponent is the product of that same number times t, which is time. Okay, so the number of years most usually is t is years. And if you put that together, you should have no problem. So for this one, the formula set up together would give you, let's see, what it would give you. The annual. Okay, what is annual? Annual means that the N is meaning a one-time thing. It's a one-time annual compounding and is once per year. Semi-annual is every 6 months or twice per year. Monthly is going to be 12 times per year, and daily is going to be 365 times per year. So what I recommend is that you set up some kind of sheet that'll help you do this quickly. I have a software that I really recommend if you're on a Mac. It's called Solver. I'll show you how that works, and you're going to see that it's going to give us the answer every time. There is a website that I'm going to recommend that you use as well. And that website is one of many you can find on the internet. You can also use a software or a calculator or whatever you really want to do to send it. You can even set up a spreadsheet to do it. But this is a fairly easy one to use. So I'm going to go here, and I'm going to put in my values. Okay, so the present value in this case, remember PV. PV in this case appears to be, why is it not right? I'm going to try again. PV is equal to $11,800. Okay, the interest rate is going to be 8% per year, which you should immediately divide by 100 to get the correct decimal value of 0.08. And T appears to be 5. Okay, T appears to be 5, and you're usually going to find yourself having to solve for one of these things, and it gives you the rest of them. Now, you may be asking yourself, where is N? What N is here? N is either 1 or 2 or 12 or 365, and we want to do these piecemeal. I'm going to do it on the website. I'm going to compare with what I get on my software at the same time. So you're going to set it up such that FE is equal to 11,800 multiplied by 1 plus 0.08 over N, and N is going to be raised to the NT power. T is 5, so 5N power. I hope that makes sense. And that's what you're going to be doing. You're going to be changing this every single time. The first one's easy, so we can kind of do that one. 11,800. And 1 plus 0.08 over 1 is just 1.08. And if n is 1, this is 5. So you would want to be really careful. I would be really careful about my PEMDASing. So it's going to be 1.08 raised to the 5th power. And then I'm going to take that number, and I'm going to multiply that. Not here. Wait. Be careful. You gotta be super careful with your grouping symbols here. And I'm gonna multiply that by 11,800. So I'm gonna get a value of, I'm gonna write it down because I don't want to forget it, I guess. 17,338 is what I think it said. I want to do it again. I wish it kept it. That would be cool. Anyway, 11,800 parentheses times 1 0.08 raised to the power of 5, 17,338 and 7 cents. Okay, so that's what we're going to put here. Now let's compare it to the website that I just gave you a second ago. Let's see what happens here. Total principal. Let's see if this works. Let's see what web is. The principal this time is not 10,000. It's 11,000. I forgot what it was. 11,800. So we're going to put that in. 11,800, and the interest rate is in percent form, so just 8% this time, right? This says just leave it in percent form. Compounded how many times? Well, we said annually, which is once per year. I'm going to put that down, and t is equal to 5, and we're going to calculate it. It should give us the same amount, but let's see what happens. We did. If you notice down there, it gave us the same value. So what I want you to do is just copy this down. Okay, copy it with your command key and paste it into the window exactly the way you see it. Then we do the same thing, changing the N only for semi-annual. Semi-annual is twice a year. That means our N is semi-annual, twice per year. Calculate and copy. You're going to get 17,466 and 88 cents. Put that in. I'm going to clear this so you can see everything that we're doing here, because now we don't need to worry about it. Here. Now monthly, go back to monthly. What does monthly mean? Monthly means 12, right? So go to monthly and don't forget to calculate, and you get 17,580.18. But I'm not even going to worry. I'm just going to copy and paste it into the window, because you can do that here. And I'm also going to go with daily. Daily, remember, is 365 times per year. Daily. Ooh, hey, be careful. The 360 or 365. That could give you a wrong answer. I'm not sure. We're going to try that out. And we're going to put that in here. I think these are really simple if you take care of it like this. It's much easier. The website is calculatorsoup.com. I just did a compound interest calculator. Do a search for that term. You should find it right away. And we're going to pop it in here like so. And I think we're ready. I think we're ready to submit. Let's see what happens. Okay, that worked. I think that's your best friend. Just stay with that and you should be okay. I wouldn't worry about it after this point. Once you find a good tool, you should just use that tool. Okay. Next one. Okay, you've got this craziness here. Let's see what it's saying. It's got a lot going on, so let's see what happens. And we need to take our keywords. We need to search for keywords in this one. Okay, so one thing we know is that we have a rate of 2.8%. Interest component quarterly, which is 4 times, and the current value is 10,000. Okay, and this is giving us the formula that we already went through already, so I wouldn't worry about it. And it's just going to ask you what value should be used for P. P is present value, R is rate, N is N. Well, just give it to it. That's an easy one. So 10,000 goes here. Okay, and R is going to be, I don't know. It could be 2.8%. I'm going to try it, but I'm actually going to go safer and say this is 0.028. Okay, it should be a decimal value or an integer. Wait, it did say integer value, didn't it? Okay, let's try it. 2.8%. Will it take that? Yeah, it will not take it that way. You actually have to give it the 0.028. 0.028. Take that number of 2.8 divided by 100. You should get that. And N is 4. That's all you should put here. How much money will you have in 7 years? Now we have our T. T is 7. So we have everything we need. So we now have 10,000, 2.8, 4, and 7. Let's put that in here. So we're going to have 10,000, 2.8%, 4 times a year, and T is 7. That's it. That's all you have to do. And you get $12,156.97, which we're not even going to register. We're just going to copy and paste it in here. No, you don't. I'm going to copy and paste that here. And hit the button. Hit the trap. We got that right. Easy. Once you find the tool, just use the tool. Number 5. Okay. You deposit $2,000 into an account, earning 2% interest. How much you have in 10? It's easy, man. There's nothing about this that's hard once you put everything in. So 2,000 goes here. And what's the rest of it? 2,000, 2%. So we're going to do 2% right away. And how many times? Monthly, which will be 12. It's even giving that to you. So it's super easy. And the t is equal to 10. Okay. Okay, this is a pretty good calculator. I'd go with this one. And you would have 24, 42, 40. That's our answer down here. 24, 42, 40. Remember that money is 2 decimal places, and therefore you should give it both digits. And then you're done with that. We only have one more here. Okay, this is an exponential function calculator. So the same thing is happening here, except it's not money. It's radiation. And you're going to have to use the e to the x power key, which is the base of e. E is a number, 2.718, dot, 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 right? It's roughly equal to 2.718. It's a never-ending number, never repeating. It's one of those giant numbers like pi. It's really important, okay? It's a natural exponent. You divide m of t. The formula is m of t is equal to a times e raised to the power of negative kt. Okay, and keep your eye on your calculator. You should be okay. In this case, the problem is 500 times e, which is a number, raised to the power of negative 0.03, and then t is, again, years. Find the mass at time t equals 0. That one's easy, because if t is equal to 0, then that becomes 0. And if that becomes 0, this is just e to the 0. And if e is to the 0, that's 1. Therefore, the answer for here is the easiest one of all. It is 500. That's all you have to put there. Okay. How much of the mass will remain after 10 years? Well, we're going to have to put that in. All right. And after 10 years, in other words, m of 10 will look like this. It'll be 500 times e to the power of a negative 0.3 times 10, which is a negative 0.3. Instead of 0.03, you multiply by 10, so it's 0.3. Okay, that's all you have to do, but you have to put it in correctly. That's the hard part. All right, so you're gonna want to have a calculator that you can do that with. I don't know if I can do e here. Let's see, e to the 1 power. Will that work? No, it will not let me do that. So I have to actually find something that let me do that. Let me go to my calculator on my machine, which is pcalc, and you can use a TI-83 or whatever. Up on that fancy calculator, and I went down to the basic Mac calculator. And if you have a TI-8, you should use it. But your Windows machine, if you have Windows, or if you have Chromebook, there should be some kind of calculator on there, even if it's an online calculator. I just didn't want to. I didn't feel like looking around for it. You can see the e to the x values are here. That's the one I'm looking for. So I'm going to do that first. I'm going to put e to the value. Okay, let's see how this works. Got to figure out how this works. So I put 0 here, and e. Well, I'm going to get 1. So I'm going to assume that I'm going to put a negative 0.3. How can I do that? Negative 0.3? No, I need to get 0. Let me try it. 0 minus 0.3 equals. Okay, that's my negative 0.3. Okay, let's see if this works. And let's say if I bring it to e, okay, that's some crazy number. I don't know if it's going to be right, but I'm going to multiply it with 500. And hopefully that's the way it works. Again, every calculator works differently, but I'm going to assume that's right. Let's say 370 to 1 decimal place, what, 370.4? Let's see what happens here. 370.4, and we did get it right. So again, it's how your calculator works that's the bigger issue here. Otherwise, it should be okay. The calculator that I was using before obviously didn't work, and I don't have a TI calculator. Just find one that works, just basic functioning, and you should be okay. One thing I want to remind you is to take the e and evaluate that first before you multiply by 500, and you should be okay. All right, so I think that's the last one for this set. We should be okay. All right, so we're going to stop with this one, and I will come back at you with the other ones post haste.